All right, welcome back to the new lesson. So, today we are going to talk about scientific notation. By the end of this lesson, I will teach you how to write any number in scientific form. But before we start with that, I will just tell you that in some books, instead of scientific notation, scientific form, you can see also standard form. So basically we talk about the same thing. Standard form and scientific form is the same thing. I will show you that there are two different types of writing a number. If we write a number like this, 4,500, you can write it as also, pay attention to this one now, 4.5 multiplied by 1,000. Isn't that right? Because 4.5 multiplied by 1,000 is equal to 4,500. Now, instead of this, we can say 4.5 times 10 to the power of. How many zeros do we see actually here? 1, 2, 3 zeros here, so that is 10 to the power of 3. So, the numbers that we see on the left is how we write the number in full, while the way you see it on the right is how you write your number in scientific notation. So basically, this way of writing a number is what we call scientific notation, while the thing that we already know is what we call writing a number in full. Now let's see how to get that actually. There is a formula that you will see, which is basically a rule that says a number is in scientific form if we have, let's say, a number A multiplied by 10 to the power of n, where A stands for a number that is between 1 and 10. What do we mean by that? A must be less than 10, but A must be also greater than or equal to 1. So any number that is greater than or equal to 1, but is less than 10, while n is any integer exponent. So for example, it can be 10 to the power of -3, it can be 10 to the power of 5, and so on. So any integer exponent. Let me ask you 2 or 3 questions so that we can see if we understand it, just using the formula. If I say, for example, 5 times 10 to the power of 4, is this number in scientific form? It is not, because the number in front has to be between 1 and 10. So 45 is not in scientific form. Or if we say 0.032, for example, times 10 to the power of -2. Is this number in scientific form? No, because of this. It has to be between 1 and 10. All right. Now that we know what a number in scientific form is and what it stands for, let's see how to write a number in scientific form. Let's start with some easier examples. If we have a number, for example, okay, the number that we used a couple of times, I will just add an extra 0 to it. We have 45,000. Now basically, we want a number that is less than 10. So if I know that it will be something times 10 to the power of something. Let us move the point. If I move it once to the left, what do I get? 4,500. Is it less than 10? No. Let's move it one more time. Is it less than 10? Not yet. Let's move it one more time. We have 45. Is it less than 10? Not yet. Let's move it one more time. What do we have? 4.5. Is 4.5 less than 10? Yes, it is. Excellent. And then we say, how many times did you move the point to reach 4.5? Because we moved the point to the left, our exponent will be positive. We moved it 1, 2, 3, 4 times. So it will be 4.5 multiplied by 10 to the power of 4. Now, just for the first time, I will explain why that is. So, 45,000 can be written as 4.5 multiplied by, what did we just say? 45,000. So it's 4.5 multiplied by 10,000, which basically means 4.5 multiplied by 10 to the power of 1, 2, 3, 4. 10 to the power of 4. We check one last time. Do we have a number that is between 1 and 10? Yes. And we have an exponent over here. Perfect. Our number is written in scientific form. Let's have another example. If we have, let's say, 4,650. We need this in scientific form. So we start moving the point. But first of all, what do we expect? We need a number that is less than 10. We multiply that by 10 to the power of something. So we move the point. One time we move the point, we get 465. Not less than 10. Move the point one more time. 46.5. Not less than 10. Move the point one more time. 4.65. Aha. 4.65 is a number that is less than 10. Excellent. Now we ask, how many times did we move the point? 1, 2, 3 times. So the final answer will be 4.5 multiplied by 10 to the power of 3. Excellent. Another example. What if we have a number that is smaller than 1? So for example, 0.000523, for example. We need this in scientific notation. Again, as our final answer, we expect something times 10 to the power of something. Now, just for the first time, we will explain it how to get the answer. Of course, we start moving the point from here. This time we move the point to the right side, which will mean that our exponent will be negative. So if we move the point to the right side, our exponent is negative. Now let's see, why is that? We keep moving the point. 1, 2, 3, 4 times. We move the point 4 times so that we can reach 5.23. 5.23 multiplied by 10 to the power of. How many times did we move the point? Once, twice, 3, 4 times. So multiply by 10 to the power of negative 4. Now again, if you ask, why is that by 10 to the power of negative 4? Because here 0.000523 is less than 1. Whenever we have such a small number, our exponent will be negative. Let's have another example. We have a number 0.042. All right. First of all, something times 10 to the power of something. Let's check it quickly. If I move the point, first of all, we notice we move the point to the right side. We have a small number, so the exponent will be negative. How many times do we need to move the point to reach a number between 1 and 10? If I move the point once, not enough. If we move the point one more time, what do we get? 4.2. And then final count. How many times did we move the point to reach that? Once, twice. We moved the point 2 times, so the final answer is 4.2 multiplied by 10 to the power of negative 2. I will give you 2 examples. You will try both of the examples by yourself, and then we check the answers together. If we have, for example, 7502 that I want in scientific notation, so something, 10, something. And let's do one more. 0.032. We need this in scientific notation. Please have a pen and paper, write it by yourself, and then we check the answers together. You can pause the video to solve it. 3, 2, 1. Good. If you pause the video, let us see if your answer was correct. Let me know in comment section if it was correct actually. So here we have a big number. Our exponent will be positive. How many times do I move the point to get a number that is between 1 and 10? If I move the point once, then I get 750. If I move the point one more time, then I get 75. If I move the point one more time, oh yeah, we have a number that is less than 10. 7.502. Finally, how many times did we move the point? Once, twice, 3 times. So it will be 10 to the power of 3. And the last example, we move the point this time to the right side, which immediately means that our exponent is negative. Now, how many times do we move the point? Once, twice, to get what number? 3.2. And as we said, we move the point once, twice. So it will be to the power of negative 2. Good job, guys. I will explain something that you get every now and then in your exams, and it could be a tricky one. So if we have, for example, 84.5 multiplied by 10 to the power of 3. Now teachers like to give this one to test you if you actually understand scientific notation. There is a problem, right? There is something that doesn't work here. What is the problem? Write in the comments if you notice what the problem is. We have 84.5 and we have 10 to the power of 3. But this is not in scientific notation. Why is that? Excellent. If you said that here we have 84.5 and that is not a number that is between 1 and 10, then you are right. How to fix that? 84.5. How many times do I need to move the point to make a number between 1 and 10? We move the point once, right? So instead of 84.5, we actually have 8.4045. But now that we move the point once, what does that mean? We just multiply that by 10, right? So 84.5 is the same as 8.45 multiplied by 10. And then we multiply this by our exponent, 10 to the power of 3. One final step. 8.5 remains the same, but we have 10 to the power of, there is 3 here, there is 1 more here. When it's multiplication, we add them. So 1 plus 3, it is equal to 4. All right, we have fixed it. So instead of 84.5 multiplied by 10 to the power of 3, we have 8.45 multiplied by 10 to the power of 4. Now we can say that this number is in scientific notation. One last example for today. If we have, for example, 0.042 multiplied by 10 to the power of 3, again, this number is not in scientific notation. Why is that, you tell me again? Right, because of this. we have a number that is not between 1 and 10. What do we do this time? 0, we move the point once, twice. Oh, but you remember, if we move the point twice, then our exponent was negative. We remember that, right? And we copy what we have over here. We copy by 10 to the power of 3. One last step. 4.2 remains 4.2. 10 negative 2, 10 positive 3. We know that we need to add the exponents. So it will be 10 to the power of negative 2 plus 3 is 10 to the power of 1. And with this we have covered scientific form, standard form, scientific notation, no matter how you call it. In the next lesson, we will actually cover how to perform plus and minus using scientific notation, and how to do multiplication and division using scientific notation. Do not forget to check the description box where you can find the links to PDFs with lots of practice questions with answers keys as well. I will see you in the next lesson. Please subscribe the channel to see the next lesson so that you don't miss plus and minus, multiply, divide with scientific numbers.